Yeah, go for it. Hi everyone, my name is JR and I'm going to talk to you about actually rendering Blender scenes on Lambda. And if you know anything about AWS Lambda functions, you're going to be thinking, why the hell? But first, I'm going to give you a short intro that my son helped me lay out on this slide. So I'm the CTO of Theodo in the US. We're a software agency based out of New York, London, and Paris, and we have about 500 people on staff. And now I'm going to talk to you about what is Blender, because I'm not sure everyone knows. So Blender is a big piece of software, design and 3D design and animation, created by this guy, Ton Rosendahl, in 1994. Following a fascinating entrepreneurial adventure involving an acquisition and the dot-com bubble, the project was open sourced in 2002 and kept growing ever since, with now tens of millions of users and very big sponsors of the open source project, and they do many things with Blender that you have no idea of, me neither. This is what Blender's interface looks like. So to a 3D designer, I guess it feels like the AWS console. Luckily enough, it has a very comprehensive Python API, and almost everything that you can do in Blender can also be automated via its API. This allows many businesses to automate tasks that would otherwise take a lot of time to accomplish. So now I'll give you a few words about what we were trying to achieve. There you go. So let's say we worked for a company that makes like dresses. They have people in China who go around and every year they find new materials that they think will be looking nice for the next season. So they scan those materials, not with their phones. And then what they want to do is that designers somewhere else in the world, they have a 3D design tool, not Blender, and they apply those materials to different parts of the dress, and they, in real time, see what it looks like. So how do we do that? So what we do is we load the scans, dump them into Blender in the cloud, render a templated scene, so that every material is like a piece of cloth on a sphere, for example, so that they have a good preview of what it looks like. So how do we do the render? We had 4 options, from the server most on the left to the server least on the right. So anything between a VM to a Lambda function. So all these solutions have different characteristics. A big one that they do or do not have is the ability to render with GPU. Here you can see that on the smallest VM that has a GPU on AWS, using the GPU is 10 times faster, but also 10 times cheaper. Lambda functions on their side, they don't have any GPUs, so it's like the same thing takes about 5 times longer. The fastest Lambda function has 6 cores, whereas the smallest GPU-enabled VM only has 4. So after this like small comparison, we decided that we would not use an EC2 instance that did not have a GPU. So spot instances, for example, were discarded. Fargate and Lambda functions can run containers, and that's nice because you can package Blender into a nice little container, not that small. But Fargate also cannot have more than no GPUs and no more than 4 cores. So we discarded that. So it left us only with EC2s and Lambda functions. So let's dig deeper into the pros and cons of each. So EC2s can go very fast with GPUs. Overall, it costs you very low, especially if you keep it running all the time, and you have unlimited RAM. Lambda is easier to scale, no maintenance, very low startup time. On the cons side, EC2s have a maintenance cost, you have to upgrade them. They're more difficult to set up, and if you turn them down between the times when you need them, Amazon may tell you that they ran out and you cannot spin one up when you need one, and that's a big bummer. So this is what our load profile looked like. So most of the time nothing happens, and every now and then we receive a batch of images that we wanted to render a thumbnail for. So this was for us really why we picked Lambda, because it meant like in under a second we could spin up as many Lambdas as we needed, render all those thumbnails, drop them in the bucket, and in under a minute the designer would see and be able to use that material on the new dress that they're designing for next year. So that was pretty cool. Now, in 15 seconds and 4 files, this is how we build it. you're not going to read anything here, so if you just Google serverless Blender, you'll find a blog post that tells you how to do it. And thank you, that's it. It feels different when you're doing it. Thank you very much.